Hi, this is Nariko. Welcome to my channel. In this video I will discuss the concept and technical drawing relationship (CTDR) with the following lessons. Principles of 2D technical drawings: sketch, profile, constraint and dimension techniques, orthographic views, perspective drawing, and sectional and material views. Lesson 1. Principles of 2D technical drawings: sketch, profile, constraint and dimension techniques. Profile techniques. 1. Orthographic projection create detailed and accurate views of objects from different angles. 2. Sectional views learn how to represent the internal features of objects by cutting them open. 3. Auxiliary views get the complete picture by adding additional views of objects from different angles. B. Constraint techniques. 1. Geometric constraints control the position and orientation of objects using geometric relationships. 2. Dimensional constraints ensure accuracy in your drawings by applying specific measurements. 3. Structural constraints create stable and robust designs by enforcing structural requirements. 4. Motion constraints simulate movement and understand how objects interact with each other. C. Dimension techniques. 1. Linear dimensions accurately specify distances between points using linear dimensions. 2. Angular dimensions measure and convey angles in your drawings using angular dimensions. 3. Radial dimensions indicate the size and position of arcs and circles using radial dimensions. Application and importance of 2D technical drawing. Engineering and architecture. Visualize and communicate complex designs for buildings, structures, and machine. Industrial design. Create detailed plans for products, optimizing functionality and manufacturing. Fashion design. Bring your fashion ideas to life by accurately representing garments and accessories. Examples of 2D technical drawings. Architectural blueprint. Showcasing detailed plans for residential and commercial buildings. Mechanical engineering drawing. Illustrating precise measurements and assembly instructions for machinery. Electrical circuit diagram. Representing the flow of electricity and the arrangement of components. Lesson 2. Principles of 2D technical drawings. Orthographic views. Orthographic projection is a method or a system for graphical representation of an object by a line drawing on a flat surface. Orthographic projection technique can produce either pictorial drawings that show all 3 dimensions of an object in one view, or multi-views that show only 2 dimensions of an object in a single view. Orthographic view is a drawing that shows a side of an object viewed directly from 90 degrees. Lesson 3. Principles of 2D technical drawings. Perspective drawing. Orthographic projection is a method or a system for graphical representation of an object by a line drawing on a flat surface. Orthographic projection technique can produce either pictorial drawings that show all 3 dimensions of an object in one view, or multi-views that show only 2 dimensions of an object in a single view. The horizon line is always at the eye level of the viewer. However, viewers can have different heights, which means the height of the horizon line will shift. That is why a distinction is made among 3 different perspectives: the bird's eye view, the normal perspective, based on ourselves, and worm's eye view. The horizon line is always at the eye level of the viewer. However, viewers can have different heights, which means the height of the horizon line will shift. That is why a distinction is made. The vanishing point is where all parallel lines intersect and is always on the horizon line. One-point perspective is a linear perspective with just one vanishing point. All vanishing lines lead to a central point. The horizontal and vertical lines, however, remain parallel to each other. Two-point perspective. Also known as the corner perspective, there are 2 vanishing points along the horizon line. This is usually used when the viewer looks at the corner of an object. This corner divides the picture. Each side follows its own vanishing point. 3-point perspective. If you want to give the viewer of your picture the feeling of height and depth, you can add another vanishing point. All vertical lines lead to this point. It is an extension of the 2-point perspective. Sectional view is that view seen beyond an imaginary plane passing through an object at right angles to the direction of sight. Sectional views are used to show the interior construction or details of hidden features that cannot be shown clearly by outside views. The cutting plane on which a section has been taken is indicated by a heavy dashed line. Arrowheads at the ends of the cutting plane lines are used to indicate the direction in which the sections are viewed. Types of sectional views. A full section view is made by passing an imaginary cutting plane fully through an object. The figure shows an imaginary cutting plane passing fully through an object and half of it being removed. In a multi-view drawing, a full section view is placed in the same position that a non-section view would normally occupy. That is, a front section view would replace the traditional front. Here's an example of a full section view. Half sections are created by passing an imaginary cutting plane halfway through an object and 1/4 of it is removed. Hidden lines are omitted on both halves of the section view. External features of the part are drawn on the non-sectioned half of the view. A center line, not an object line, is used to separate the sectioned half from the non-sectioned half of the view. Half-section views are most often used on parts that are symmetrical, such as cylinders. Here's an example of half-section view. Rib and web sections. The thin webs are not normally sectioned even though they lie in the section plane, according to ISO recommendations. A good way to accept these exceptions to the general rule are to imagine how complicated the drawing would look if they are sectioned. Here's an example of rib and web view. Hatching lines are thin lines and should preferably be inclining at 45 degrees. They should be evenly spaced. If there are two or more adjacent section parts, the hatching lines should either be of different spacing or different direction. However, hatching patterns should be the same for separate areas of a single object. Thank you and don't forget to subscribe to my channel.